Hello everyone, in this video let's discuss how to solve the binary search tree insertion and deletion. In the same video let's discuss the insertion and deletion in the binary search tree. First they will give the list of elements and they say draw the binary search tree. The first step will be inserting the values. So first let insert the values, then try to delete. Now how we will insert the value means, first, if you see the binary search tree, it will be having two important aspects. First one is the binary search tree. Each node can have maximum of two child. So if you consider this as a node, it can have 0 child, it can have 1 child, whether it may be left or right, and it may have 2 child. Maximum is 2 child for each node, and this node will be considered as a separate node, and this can have 0 child, 1 child or 2 child, like that. Each node must be having maximum of 2 child, 0, 1 or 2. Now second one will be the left node must be less than the root node, and right node must be greater than root value. Now if you consider this as the node or the root node, the node which will be coming towards the left side must be having the lesser value, that is left node will be having less value than the root, and the right node will be having the more value than the root. So this is more value, this is less value. Now let's try to insert the value. The first element is 11. So 11 will be inserted directly. Now I must insert 6. First I will compare with this root value. So since this is the first element I inserted, this will become the root. Now if I compare with 11, the 6 value, 6 is less than 11. 6 is less than 11. So if you see where it must come towards the left side. So it will come here. Now 6 is over 8. I will compare with the 11. First you must come from upside to downside, that is from the root value. So if you compare with the 11, 8 is less than 11. So it will come left side. But 8 is greater than 6. 8 is greater than 6. So it will go right side. 8 is less than 11, so it came left side. But it is greater than 6, so it went right side. Next it is 19. 19 is greater than 11, so it will go right side. Next 4. 4 is less than 11, 4 is less than 6. So 4 will be left side here. Next 10. So 10 is less than 11 but greater than 6 and also greater than 8. So it will come here. Greater means right side, lesser means left side, like that. Next 5. 5 is less than 11, less than 6 and greater than 4. Less than 11, less than 6, greater than 4. Greater than 4 means right side. Next it is 17. 17 greater than 11 but less than 19. So it will come left side. 17 is here. Next is 43. 43 greater than 11, greater than 19. So it will come to the right side. Next I must insert 49. 49 is greater than 11, greater than 19, greater than 43. So it will go towards the right side. Next it is 31. So 31 greater than 11, greater than 19, but less than 43. 31 is less than 43. So it will come towards the left side. Now we have inserted all the values. Now let's discuss the scenarios of deletion. So the deletion will be having 3 scenarios. 3 scenarios or 3 cases. First one will be deleting the node with 0 child. Deleting the node with 0 child. So if you see the node with the 0 child and if you want to delete, here if you see 5 is having 0 child, 4 is having 1 child. If you see 5 not having any child, so it will be considered 0 child. 10 is having 0 child, 31 is having 0 child, 17 is having 0 child, 49 is having 0 child. Therefore, you can conclude the leaf nodes will be having 0 child node now. So, you can directly delete them. Now, if I want to delete 10, so if I want to delete 10, first I will check how many number of childs are there. For 10, there is no child at all. That is 0 number of child. So, it is the leaf node. So, what I can do, I can directly delete. So, if you directly delete like this, so only this much is left. So, draw another graph, just delete the 10, don't write 10. So, it will be the deletion of 0 child. Now, let's delete the 1 child. If I want to delete the node which is having 1 child, so I will write 10 as it was earlier. When I inserted, it was like this only, no? So, you must write again like this. Now, I must delete 1 child node. So, if you see, 4 is having 1 child, 8 is having 1 child, and no one of them. So, this is having 0, 0 child, 2 child, 2 child, 2 child, 2 child, 1 child, 1 child. Now, whether I can delete 4 or I can must be delete 8. In the exam, they will give you delete these values. So, I am giving the scenarios only. So, now, I want to delete 8. So, what I will be doing is, replace the value you want to delete or the node you want to delete with its child node. Since we are having only 1 child, so to delete the 1 child node, so what I will be doing, swap child node and parent node. So what you must do, swap the child node and parent node. So what it will be, 10 will go here because for 8 10 was the child and 8 will go here. Now I swap the parent and the child. Now if you see, 8 is having the 0 child. Now 8 has become the leaf node. So swap the child node and the parent node and directly delete. Why I can directly delete? Because 8 has become the leaf node. Leaf node means 0 child. 0 child means directly delete. So I will delete directly. Now I deleted 8. What I did? I swapped the 8 value was here and 10 value was here. Since it was having only 1 child, I swapped the values of child value and parent value. 10 came here, 8 came here. Since 8 came here, it was having the 0 child. It means first condition. So I can direct 8 directly. Now let's go to the final case, that is deleting the node with the 2 child. If you see here, 6 is having 2 child, 19 is having 2 child, 43 is having 2 child, 11 is having 2 child. How you can delete? Now, the third case is 2 child node, how you will delete. So to delete the 2 child node, you will be having the 2 condition. So you can use one of them. One will be using inorder successor. Or the second one will be using inorder predecessor. So what is this? Now let's consider I want to delete 11. So 11 is having 2 child. I can use inorder successor or inorder predecessor. So inorder successor, you keep it in mind, you must use the smaller value. So what is it? Successor means front, that is right side. So I want to delete 11, I will see the right side. So full right side will be called as the right subtree. For if you consider, if you want to delete 19, what will be the right subtree? 43, 31, 49. Like this. You must draw the right subtree. In the right subtree, you will be seeing the smaller value. Which is the smaller value? 17, 19, 43, 31, 49. Which is the smallest value? 17. So, you must replace 17 and 14. That is swap. 17 will come here and 11 will come here. Now, if you see, 11 is having 0 child. Now 11 is having 0 child. 0 child means first case, that is directly delete. So what you did in this process, you searched for the smallest element. It was 17 here and it was 11 here. You searched for the smallest element in the right subtree and you swapped the element with the element which you want to delete. Now the element which you wanted to delete become the 0 child node and then you can directly delete 11. Now let's go with the second one, that is inorder predecessor. How to delete? So in this inorder successor we use the right subtree. In this one inorder predecessor we will be using the left subtree. This is the left subtree of 11 node because I want to delete that one. So in the left subtree, which will be the bigger value? Here we took the small value, in predecessor we will be taking the big value. So which is the big value among 6, 4, 5, 8, 10? 10. So what I will be doing? I will be replacing 10 and 11. 10 will come here and 11 will come here. And 11 become the 0 child node, you can directly delete. So easy step. In the inorder successor, you will be choosing the smaller value and replace and delete. In the inorder predecessor, you will be choosing the bigger value, replace and delete. So easily you can solve this problem. Now if you see, for example, I must delete 19. So the left subtree, that is inorder predecessor, we are having only one element. So I can swap 17 here, 19 here and I can delete easily. In the right subtree, that is inorder successor, smaller value among 43, 49 and 31 is 31. 31 and 19 will be replaced, that is swapped, and 19 will become the 0 child node and you can delete easily. So hope you understood the concept of the binary search tree insertion and deletion. If you have any doubt, please comment below. If you liked the video, please subscribe and support us. Thank you.